that you can resolve these two objects. This is the example when two light sources that is quite far apart, and when the light pass to a hole. These two light source. Okay, you have a hole and you have two light source, and this is far apart like this. And once the light is passed through the hole, it produces the diffraction pattern. You can see this is the diffraction pattern. This is the center fringe, and this is the first bright fringe. This is the dark fringe. Okay. And when you make these two objects come closer, the diffraction pattern of these two objects will merge, and it look more like a single object. But for this figure, you may can notice that it may come from a different object. But for the last figure, the light comes from two sources, but from the diffraction pattern, you see that it is like a one object, and you cannot resolve these two objects. It is because the diffraction phenomena that limit our ability to resolve two objects when you look through the optical instrument. So, how close that we still can resolve these two objects? We call this the Rayleigh criteria. The Rayleigh criteria. The Rayleigh criteria say that when the central maximum of one image fall on the first minimum of the other image of another image, the images are said to be just resolved. Okay. If you look at this figure, you can see that this brown line represents the diffraction pattern from the first object S1. Okay, and the height of this curve is the intensity of the image. Okay. And if the center of S1 is at the dark fringe of S2, it means that we can see S1, right? Because it's at the dark fringe of the S2. And also if S2, this is the diffraction pattern of S2, and the bright fringe of S2 is at the dark fringe of S1, and we can see this bright fringe. But if it is close, you can see that the bright fringe come together and merge, and you just see that it is just one bright fringe, like this one. Okay, so the condition that these two objects can be resolved is that the bright fringe for one object is on the position of the dark fringe of another object. Okay, so in this figure we say that it's just resolved. This means that we start to see that the pattern comes from the different object. Okay, and also on this, you can see that this is the dark fringe for the blue line, and this is the dark fringe for the brown line. So we say that these two objects are just resolved, and we call it this the Rayleigh criteria. Rayleigh is the name of the physicist, and it gives the criteria that two objects from any optical instrument, the light has to pass the narrow slit or the circular aperture. If it is a circle, we call it a circular aperture. But if it is a slit, okay, it's a line, we call it a slit. And this is a condition that we can resolve these two objects. Okay. For a line slit, the Rayleigh condition tells us that the angle, if we draw the light ray from the first object and the second object, and the angle between the light ray is theta, and we want that these two objects can be resolved when the light pass through the slit. It means that this angle have to be at least equal to the angle for the first dark fringe. Okay, this is for the first dark fringe. Why? Because you can see that if the light from the first object has the bright fringe here, and we want it to be on the dark fringe of the second object. We want it to be on the dark fringe on the second object. It means that if you look at the angle theta, okay, just think like this. If the bright fringe is here, and you want the dark fringe for the first object, this is the dark fringe for the first object. So, what is the angle? What is the angle here for the first dark fringe? We will have that the angle have to follow this equation, right? But this angle, if you want to resolve the image of these two objects, this angle have to be the angle for the ray for the second object. Okay, the ray for the second object have to be at this angle. Okay, so it means that if you draw the line for the ray of the second angle, it have to be this angle theta, that the bright fringe for the second object have to be at the dark fringe for the first object and on the opposite direction. So this is the condition that the central fringe or the bright fringe of the first object will be on the dark fringe of the second object. And if we assume that this angle is quite small, okay, or if we assume that the lambda is much less than a, okay, if the lambda is much less than a, or the angle is quite small, if the lambda is much less than a, so you can see that this number is very small, right? When this number is very small, it means that sin theta is very small. And when sin theta is very small, we can approximately say that sin theta is about theta. Okay, so when sin theta is about theta, it means that we can replace this sin theta with theta. It means that if the light that pass through the slit has a wavelength lambda and the slit width is a, the angle of the light ray from two objects that we can resolve will be at least this value. Theta mean is equal to the lambda over a. Okay, so that is the condition for the Rayleigh criterion, that the angle between two objects have to be like this, then we can resolve the image from these two objects. Okay, that is what we just describe. This is the real situation that when they discover the planet Pluto. Nowadays, the planet Pluto, we do not call the Pluto as a planet anymore. And as you may learn when in your elementary school that in the solar system has 9 planets, right? But now it has only 8 planets. The Pluto is just they call it I can't remember it's like it's too small to be a planet. So it's a we may call it a mini planet, something like that. But I officially it called something, but I cannot remember. But it's too small to be a planet. Anyway, this is a figure that they first. Then we know that we have we know for a long time that in the solar system we have the Pluto